When we have a limit of f of x as x approaches 2 of the function x plus 5, well, our first plan of attack, plan A, is always direct substitution. And so that means I'm going to put a 2 anytime I see x, because x is squeezing towards 2. Well, let's try it. 2 plus 5 is 7. That's our answer. Now, what does this mean? Well, our function is x plus 5. Y-intercept of 5, slope of 1 over 1. So this is what our graph looks like, y and x-axis. And so we're saying, as x squeezes in on 2 from both sides, the right and the left, what is the trend in y? Well, if direct substitution works, then we get a point on our graph. And I hope you can see that the y values are squeezing towards 7. Notice, we find the limit on the y-axis. It's 7 there. And if the limit can be found by direct substitution, then we're going to have a point on our graph. As x approaches 2, y is approaching 7. In fact, the limit is reached. The limit of f of x as x approaches 4 for f of x equals 3x squared. Our first plan of attack, plan A, is to use direct substitution. And if it works, we're thrilled. 3 times 4 squared. We have to follow PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. That means we're going to go 4 squared is 16 times 3 is 48. Oh, we found the limit. That's the trend in y. What's happening here graphically? Well, 3x squared looks like our parent function, y equals x squared, but we've got a vertical stretch by a factor of 3. So this point over 1 up 1 becomes over 1 up 3. And so our graph is going to be kind of something like that compared to our parent function y equals x squared. And we're saying as x approaches 1, 2, 3, 4, where is the y? And we get this point 448. Notice where the limit is found. The limit is the y value. And because direct substitution worked, then we actually have a point on our graph. That's what that's going to mean for us. The limit of f of x equals the square root of x plus 4 as x approaches 5. Our first line of defense, plan A, direct substitution. The square root of 5 plus 4 is the square root of 9, and we know the square root of 9 is 3. So as x squeezes in on 5, y is trending towards 3, and there is our answer. We found the limit by direct substitution. Well, what does this look like? Well, we know the parent function of the square root function, y equals the square root of x, looks like that. It goes through 0, 0, 1, 1, 4, 2, etc. Inside the radical affects the x, so this is going to be the crazy cuckoo bizarro bonkers world. It's actually going to shift us to the left 4. So 1, 2, 3, 4. That's going to be our first point. We know that anything in the radical, x plus 4, has got to be greater than or equal to 0. So x, our domain, will be greater than or equal to 4. And our function is going to look like this. And we're saying, as x approaches 5, 1, 2, 3, 4, 5, where is y approaching? I'm going to erase my parent function. Well, y is approaching 3. Notice we have this point, 5, 3. As x approaches 5, y approaches 3. And because we get because we get the limit through direct substitution, we have this point 5, 3 on our graph. The limit of f of x as x approaches 3 of 2x over x plus 4. Of course, I'm going to try direct substitution every time. Hopefully it will work. And this will give us 2 times 3 over 3 plus 4, which is 6 over 7. That is our limit. That's the trend in y. As x squeezes it on 3, y is going towards 6 over 7. Well, what does this graph look like? Well, look at our denominator, x plus 4. Set that equal to 0, and x equals -4. Denominator equals 0. The graphical feature is a vertical asymptote. Here it is. It's a no-fly zone at x equals -4. Look at our exponents here. We've got x to the first and x to the first. We go to our ratio of lead coefficients. That's 2 over 1. So y equals 2 over 1 is our horizontal asymptote. And this is y equals 2. And we know we have the point as x approaches 3, y goes to 6 over 7. So I go over 1, 2, 3, and up 6 over 7. So my graph is going to look something like this. It's going to hug this asymptote, go through 0 over 0, and go through my point there. And it's also going to be here like this. Now, I took pre-calculus and algebra 2 to learn how to do that. I found my y-intercept there at 0, 0. So what's going on here? As x is approaching 3 from both sides, y is going to 6 over 7, not quite 1. Notice the limit is the y value. And because the limit was found by direct substitution, we actually have this point, 3, 6 over 7. If we have the limit as x approaches 2 of function x cubed minus 5, of course I'm going to use direct substitution. Hopefully that will work. Let's see. 2 cubed minus 5. I have to follow my order of operations PEMDAS. 2 cubed is 8 minus 5 is 3. So there it is. It worked. I was able to get the limit. The limit is the y value. Well, what is going on here? We know that the parent function y equals x cubed looks like this. Here's y equals x cubed. We're going to move it down 5. So it's going to look something, if I erase my parent function, I'm going to move this all down 5. It's going to look something like this. And it's going to have a y-intercept at -5. Now, I'm curious, what happens when x squeezes in on 2 from both directions? Where is the trend in y? You guessed it, it's 3. Notice, I'm finding the limit from the y value. And because when I substituted in 2 directly, I got 3, this means the limit is reached as well. We're going to have a point right there.